Hello class, welcome back to the dojo. It's me, Jacob, or the number ninja, or sensei. This is going to be lesson 2 now in our pre-algebra series. So last time we were talking about real numbers, and this time we're actually going to be talking about our next topic, integer operations. So yeah, without further ado, let's get right into it. All right, integer operations. So when we're talking about integer operations, there's 4 that we're focusing on for now. That's going to be addition, subtraction, multiplication, and division. Addition and subtraction are opposites, and multiplying and dividing are opposites. So we're going to cover them in pairs here. Let's start with, there's basically 2 different ways to do this addition and subtraction, or 2 things to think about. Whether they have the same sign or they have opposite signs. Okay. So this, an example of same sign would be 2 positive numbers, or 4 plus 4. I know this says it's addition, but what we really want to realize is this first 4 is positive, and because we're adding it, the second 4 is also positive. This is probably the easiest one. I'm sure you all know that's just 8. The other example of same, though, is 2 negative numbers. Another way you might see this represented is a negative number subtracting another number, right? So let's call it -7 minus 2. These are both negative for all intents and purposes, right? Even though we're just subtracting a positive 2, that makes it negative. The same idea will happen here as with the 2 positive numbers. We're just going to add them together and then keep the sign, okay? So -7 minus 2, well, 7 plus 2 is 9. And they were both negative, so our answer should obviously stay negative. That's the easiest way I found to think about it. If they have the same sign, the 2 integers we're combining have the same sign, just add them together and then keep that sign. And that works no matter how large the number is. So let's just say we have -37 minus 12. Again, these are 2 numbers with the same sign, so let's just add them together. I'll do that over here really quick. 37 and 12, 2 plus 7 is 9, 1 plus 3 is 4. Okay, 49. Oh, but wait, both of our numbers were negative, so our answer is negative. So hopefully that's a simple way to do it. It works every time, as long as you're doing 2 digits at once. So, and that's for addition and subtraction. Now the more difficult version, or the more difficult category, is if we have opposite signs. So this will be something like a -3 plus 4, or maybe a 7 minus 2, right? Either way, whichever one's negative, it's the same idea. Something else you can see, and we'll cover that in a second. These ones, we're going to do a different thing. Different signs, we subtract them, okay? I know that sounds a little bit weird because this first one is addition, but different signs, we subtract them. What we will do is we will take our number that's further away from 0, and we'll put that on top. So in this case, 4. And we will then subtract the second number, which is 3 here. We will subtract them and get a 1. And then we will keep the sign of the number further away from 0, which in this case is 4, which was the positive number. So our answer is a positive 1. The same thing happens with the second one, but this is what you would normally expect, so we all kind of know it's a 5. Where this method is really beneficial is with larger numbers. Okay, so larger numbers that are still integers, like let's say -46 plus 13. Or maybe you could see it the other way around, which is exactly the same, 13 minus 46. These are the same question, right? They just flip the order of the numbers. But both ways is a little bit difficult to do. You can make a number line, right, and move along the number line. But with numbers this large, that would have to be a big number line with a lot of different tick marks, and that would take too long. So we're not going to do that. We're going to do the same method. Different signs, so we subtract them. We take our number further away from 0, which is 46. And then we subtract our 13, which is our number closer to 0. I'm getting really bad at connecting these 4s. 6 minus 3 is 3. 4 minus 1 is 3. So our number will be 33. And then remember, we keep the sign of our number further away from 0, which here was that negative 46. Our answer is negative 33. And then the same thing would happen if we did the second one with this method. Hopefully that's a little bit easier way to do the opposites. One other thing to do, or that you might come across, is stuff like this. So I'll just cover this the way you understand. So 5 plus minus 4, right? This is something you might see with a negative number in parentheses, but it says addition. These, it might say addition, but remember these are opposite signs, so we are going to subtract them anyways, right? 5 is further away from 0, 4 is closer, subtract it to 1, and we keep the sign of our larger number, which is positive. And then the other tricky thing you might see is something like this. So let's just say negative 8 minus, but then minus a negative number like negative 3. Whenever we see this where we're subtracting a negative number, it's actually saying that we want to do negative 8 plus a 3. The reason for this is a little bit counterintuitive, but it's the idea of if we had a negative thing that was actually making our number smaller. So if we then get rid of it with subtraction, our number should be bigger as a result because the thing that was weighing us down is no longer there. The easier thing to think about might just be our two negative signs will combine and turn into one addition sign. There's no like math reasoning behind that, but something that could help you think about it a little bit more. In this case, then, we see that we actually have different numbers, so we will be subtracting them, right? It looked a little bit confusing at first with 3 negative signs here, but we are actually subtracting them because they are different signs. And again, our number further away from 0 here is the negative 8, so that goes on top. We get our 5 as our answer, and we keep the sign of our number further away from 0, so we have negative 5 here. Now I'm going to give you guys an opportunity to do one on your own. I'll try to make it a little bit difficult, that way you guys can challenge yourselves, but I will go over it right after as well. So, and you know what, let me keep this on the screen in case you want to refer back to it. So let's try something at least 2 digits here. Let us try a negative 25 plus 17. So if you want to give that one a try, I'm going to encourage you to pause the video and try to figure it out, and then I'll go over it when you guys get back. All right. Hopefully you guys were able to do that. If not, no worries. We're going to cover it here. So again, the first thing we always want to do, check our signs. We have different signs here, and when we have different signs, we subtract. So we're going to take our number further away from 0, which is our 25, and take our second number. We're going to subtract them. We actually have to do some carrying here, so it's a little bit more challenging. But the 2 becomes a 1, the 5 becomes a 15. 15 minus 7 is 8, and the 1s cancel out to become a 0. So our number will actually be an 8. And then again, we keep the sign of our number further away from 0, so it's a negative 8. Yeah, hopefully that's a good coverage of adding and subtracting integers. Again, I'll write it down just to make it super clear. And this is what you guys really need to remember, because this makes it so much easier than trying to think about what you should be doing on every question. Same sign. We add them and keep their sign, right? If they have different signs, subtract and keep the larger sign, or the, sorry, I have to be careful of my word because that's technically incorrect. Large or positive numbers are always larger than smaller numbers. Sign of the number further away from 0. This is the most important thing to remember about what we just covered here. If you remember this, these questions become so much easier than if we're looking at something like a negative 3 minus 10 and trying to remember what we're supposed to do. Because, oh, it says subtraction, but how do I subtract 10 from a negative 3? Don't even worry about that, right? Because negative 3 minus 10, how do we do this? I don't know. Let's just not bother, right? This right here, this is the holy grail, at least from my experience of both doing math myself and teaching people. This is what helps them remember it the most. So with that said, let's talk about our other pair, multiplying and dividing. This is, of course, our other opposite pair that we're talking about here, because multiplying and dividing cancel each other out. And we'll do more advanced stuff with that in the future. But multiplying, dividing. There's a similar thing going on here where we care about the signs. Because 3 times 7, that's something you guys know how to do. Hopefully, that's just 21. 14 divided by 2, also something hopefully you guys know how to do, is 7. Where things get a little bit more difficult and what we're going to focus on is what we do if they have different signs. And again, I'm going to try to boil it down to a straightforward rule for you guys. That way it's easier to remember. Same signs, positive. Let me actually write that down. I'm going to write it down again. But same signs, positive. Different signs, negative. So this one is slightly different than what we were doing with adding and subtracting. Because adding and subtracting, the size of the numbers actually mattered, right? Whichever number was further away from 0, that's the sign that we kept. Or if they were the same sign, you know, we just keep the sign. But in multiplying and dividing, it's a little bit different. Let's say we have 3 times 7. These are both positive numbers, so our answer is a positive 21. However, the same thing would happen if we had a negative 3 times a negative 7. They are both negative numbers. Our answer is a positive 21. Where things change is if we had a negative 3 times a 7. All of a sudden, our answer is negative 21. And the same thing happens if it's a negative 7 instead. We get a negative 21. Right? The thing we're focusing on is same signs, positive. Different signs, negative. That's kind of all there really is when it comes to doing integers. Hopefully that all made sense. Sometimes you might see like parentheses around this, but that's just to indicate that it's negative. Same thing here. This one you'll probably see more, just to not make you think you're doing times minus. If you ever see a times minus, just know it means times a negative number. Subtracting signs and negative signs are basically interchangeable, so hopefully don't get too caught up on that. Let's see, is there anything else we need to cover here? No, so I think that's actually everything for integer operations. As things get more complex, we'll dive into it at a more detailed-oriented level. But for now, that should be good. And now let's jump into our final topic, which is going to be square roots and cube roots. Wow, okay, so another great tease from a previous version of myself. Just giving you guys a quick look into what we're going to be covering next time. Hopefully something you guys are looking forward to. Cube roots and square roots I know are very exciting. But yeah, that's all I had for you guys today when it comes to integer operations. Hopefully you guys are learning and finding it useful. Keep training in the dojo with me, and I promise you guys will be black belts in no time. So with that said, good luck everybody, and have a good one.